phase changes. Of course, heat can bring changes in phase since it is directly linked with temperature change. Due to heat, phase changes occur at which during heat loss, gases becomes liquids and eventually becomes solid. On other hand, if heat is gained, solids become liquids and eventually become gases. The heat per unit mass required to change a substance from solid to the liquid phase or vice versa at its melting temperature is called the latent heat of fusion, which is denoted by L sub F and is given by the formula L sub F is equals to Q over M. So when does this phase change occur? So at what certain temperature will we achieve this latent heat of fusion? So this occurs during the melting point, the temperature at which the change occurs during fusion. So if the phase change involves liquids to gas or vice versa, so dito naman pumapasok si latent heat of vaporization, which is denoted by L sub V. So ito yung tatandaan natin. When we talk about latent heat of vaporization, it occurs or it is concerned with the phase change from liquid to gas or vice versa. So that is what we should remember. So LV is a liquid to gas. On the other hand, the LF or the latent heat of fusion is concerned with solids turning into liquids and vice versa. So yun yung tatandaan natin. So this occurs during boiling points naman, yung latent heat of vaporization. So same formula, difference lang is LF is changed with LV. So LV is equals to QM. So boiling point naman is the temperature at which the change occurs during vaporization. So syempre hindi lang naman yun yung change of phase na concerned in thermodynamics. So here are some other change of phases which most likely narinig nyo na rin dati when we are talking about chemistry. So condensation, the vapor turns into liquid. Freezing occurs when liquids turns into solid. Sublimation occurs when solid naging gas bigla. And deposition occurs naman kapag gas na naging solid bigla.
How much water remains unfrozen after 50.2 kJ is transferred as heat from 260 grams of liquid water initially at its freezing point? So here you will use the formula Q equals mLF, where LF is the latent heat of fusion of water. So we will find the mass, so that is Q over LF. So the latent heat of fusion of water is 334 kilojoule per kilogram or 334 joule per gram. So it is in kilojoule, so you convert the units as well. So 50.2 kilojoule over 334 kilojoule per kilogram equals 0.150 kilogram, and that is equal to 150 grams. An insulated thermos contains 130 cubic centimeters of hot coffee at 80 degrees Celsius. You put in a 12-gram ice cube at its melting point to cool the coffee. By how many degrees Celsius has your coffee cooled once the ice has melted and equilibrium is reached? Treat the coffee as though it were pure water and neglect energy exchanges with the environment. This problem will use calorimetry. So, by equilibrium or the law of heat exchange, we use Qi equals Qc, that is the heat of ice and the heat of coffee. So that is equal to Mi, the mass of ice, times the latent heat of fusion since it involves phase transition, particularly in melting of ice. As you put the ice in the coffee, it will melt. Then plus mc delta T, that is the heat using calorimetry, So Mi is the mass of ice. Cw is the specific heat capacity of water since ice is the solid form of water. So you will use its specific heat capacity because if you melt ice into water, it will become liquid. Multiply by the change in temperature, that is the final temperature, that is the temperature as ice melts, minus the initial temperature, which is the melting point of ice, equals QC, that is the mass of water since we treat coffee as pure water. So the mass of water multiplied by the specific heat capacity of water times the change in temperature, in this case, that the temperature of ice, that is 80 degrees Celsius, minus the final temperature of ice, which is the initial temperature of the coffee. So that is equal to 12 grams multiplied by 80, that is the latent heat of fusion of water, plus 12 grams times 1 cal per gram degree Celsius, that is the specific heat capacity of water, multiplied by T equals 130 grams multiplied by 1 multiplied by 80 minus T, and solving for T will lead you to 66.5 degrees Celsius. For the change in temperature, that is 80 minus 66.5 degrees Celsius, that is equal to 13.5 degrees Celsius.
Thank you for listening. I hope you learned something today and see you on the next discussion video.